We're all using AI these days, right? But have you ever stopped to think about what makes some AI systems feel, well, brilliant, while others just feel kind of clumsy? Today, we're pulling back the curtain on the actual architectural blueprints that build truly robust, adaptive, and intelligent AI. Let's dive in.
So you've got this super powerful AI. It can write, it can code, it can generate images, but is it actually smart? I mean, is it efficient? Does it learn from its mistakes? And maybe most importantly, can you rely on it over time? Because, and this is the key, without the right architecture, even the most powerful AI can be incredibly wasteful, super frustrating to work with, and honestly, dangerously unreliable out in the real world. So how do the pros get around these problems? Well, that's where something called AI design patterns come in. You can think of these as proven reusable blueprints for building AI systems. They're kind of the secret sauce that separates a weekend project from a professional, trustworthy system that can actually think, adapt, and grow.
All right, so first up, let's tackle the big one, the one that hits you right in the wallet: cost and waste. How do you stop your AI from just burning through money and compute time on really simple tasks? Let's meet our first pattern, which I like to call the smart AI traffic cop. Okay, picture this. We've all seen it happen. A user makes a super simple request, but your system sends it to this massive, complex, expensive model. Now sure, the AI gets the job done, but it's like using a sledgehammer to hang a picture frame. Total overkill. Now just imagine that happening thousands of times a day. All that extra processing power adds up to a whole lot of wasted time and, you guessed it, a lot of wasted money.
So the solution? It's a way smarter approach called the escalating evaluation pattern. Instead of one giant, one-size-fits-all model, you have a whole fleet of them, from small and cheap to big and powerful. And here's the genius part. A smart router agent acts like a traffic cop. It looks at every single request and sends it to the most efficient model that can handle the job. No more waste.
So how does this router actually work? Well, one of the most common ways is called the sequential chain. It's actually pretty brilliant in its simplicity. The router is programmed to always try the cheapest option first. It zips the request to the simplest model, gets a result, and asks itself, hey, is this good enough? If the answer is yes, boom, we're done, fast and cheap. If not, it just escalates it up the chain to the next model until it hits the quality bar.
And don't think this router is just some dumb switch. No. It's got its own brain. It might use some simple if-then rules, or maybe some clever shortcuts. Like if the query has medical terms, send it to the expert medical model. It could even be context-aware, remembering what you've asked before to make a better choice this time. And in the really advanced setups, the router is its own little AI, trained just to predict which of the bigger AIs is the perfect fit for the job.
All right, so we've made our AI efficient. It's not wasting our money anymore. Great. But is the stuff it's producing any good? Now we're going to level up and tackle quality. How do we solve for an AI that kind of has the memory of a goldfish and needs you to constantly hold its hand?
And this quote right here, it just hits the nail on the head. It's that feeling, right? You ask an AI to write a report. It gives you a first draft. You ask for a revision, but because it has literally no memory of what it just did, you have to feed it all the context all over again. It becomes this endless, super frustrating loop of trial and error.
So what's the fix? Well, it's a pattern called autonomous self-correction. With this, we introduce a new agent that basically acts like a persistent project manager. It holds the main goal in its mind, it remembers all the context from every single interaction, and it guides the AI through revisions until the final output is perfect, all without you having to constantly repeat yourself.
And what's so cool is how this agent thinks. It's not just one thing. It's more like a little team of specialists working inside the AI. You've got the boss, whose only job is to keep its eye on the prize, like write a publishable article. Then the critic jumps in and asks, is this paragraph any good? The planner then figures out the next logical step. And maybe most impressively, you have the strategist, which is like an internal coach, helping the AI learn from its own mistakes so it actually gets better with every single try.
Okay, so our AI is efficient and it's producing high-quality work. We're on a roll. But now we come to the final boss, reliability. How do we make sure our AI stays accurate, sharp, and safe when the real world is constantly changing all around it?
And when we talk about reliability, there's one big, scary monster we have to face: model drift. This is what happens when an AI's performance slowly gets worse over time, just because the world has changed. The live data it's seeing today no longer looks like the data it was trained on months ago, and so its predictions get, well, they get weird, and sometimes silently and dangerously wrong.
And this timeline just shows you how bad the old way of fixing this is compared to the new way. I mean, look at this. Manually, it can take weeks, even months, for a human to even notice there's a problem. Then more weeks to retrain the model and finally deploy a fix. And all that time, your AI is giving bad answers. But with a proactive pattern, drift gets detected in hours, and an automated retraining process kicks off right away.
And this is where our next pattern comes in to save the day, the proactive retraining pattern. What we do is add a drift monitor agent to our system. Its only job is to watch the live AI 24/7, constantly checking for any signs of drift. The second it spots a problem, it sounds the alarm and automatically kicks off the process of building a new, better model. It's basically an AI early warning system.
So to get how this works, you just need to know two key terms, champion and challenger. Think of it like a title fight. The champion is your current model, the one that's live and in production. The challenger is the new model being trained up behind the scenes on all the latest data. The goal is to get that challenger ready to step into the ring and take over the moment the champion starts to stumble.
Okay, that's great. But what if pretty good isn't good enough? What about those critical systems? We're talking financial trading, medical diagnostics, where you need zero downtime, where you have zero room for error from a flawed model, and you definitely can't risk swapping in a new challenger that might have its own secret problems. How do you guarantee absolute safety and uptime?
For those situations, you need the ultimate safety net. You need the shadow model deployment pattern. This is literally like getting a stunt double for your AI. A brand new, retrained model runs in the shadows, getting real-world workouts and being tested like crazy before it's ever asked to take over the main role.
So here's the brilliant part. A special shadow agent sits in front of everything. When a live request comes in from a user, it secretly makes a copy. The original request goes to the live champion model, and the user gets their answer just like always. But that secret copy, it gets sent to the shadow model. The shadow's answer is never shown to the user, but it's logged and compared against the champion's answer. This is the whole key. You get to safely test drive the new model on real-world traffic without any risk to your users at all.
But of course, there's always a trade-off, right? And this chart lays it out perfectly. A standard AI, that first bar, yeah, it's cheap to run, but you're carrying a huge risk of model drift. Proactive retraining is that nice middle ground. But the shadow model, that third bar, is definitely the most expensive because you're literally running two systems at once. But in exchange for that cost, you get the absolute lowest possible risk. And for mission-critical systems, that's a trade-off you have to make.
So having the right tool for the job, even when it's more expensive, can be absolutely critical. And that's really the whole idea here, isn't it? These patterns aren't just a few isolated tricks. They're a powerful, integrated toolkit for building mature, professional-grade AI systems that are efficient, intelligent, and most of all, reliable. So let's just do a quick recap. To fight inefficiency and waste, we brought in the smart traffic cop. To fix poor quality and that no memory problem, we use the persistent project manager. To combat model drift, we set up the early warning system. And for the ultimate safety net, we deployed the AI stunt double. Each one solves a critical problem, building on the one before it. And that really leaves us with a pretty powerful and maybe slightly mind-bending idea. Each pattern we've talked about, the traffic cop, the project manager, the early warning system, it all makes our AI more and more autonomous. It can route its own tasks, it can correct its own work, it can even retrain itself. So as we build these increasingly independent systems, the next great challenge is really one of alignment. How do we make sure that in all their complex adaptive behavior, they never, ever lose sight of our true ultimate human intent? Something to think about. Thanks for joining us.